mad at myself. So that's a binomial, right? And you could represent it with different things. You could even do something simple like x plus y. That's a binomial. One term plus or minus, and then another. So we're going to multiply two of those things. Yeah.
I was listening to the recording from yesterday.
Yeah.
This or whatever, and it kept cutting out. So I don't know if there's a.
Yeah, it's called our computer suck. Like being completely honest, because it lags behind. Like it just can't record as fast as it's going. Yeah, it's frustrating, but
Your recording is frustrating.
yeah,
That's okay.
now when it cuts out when you're watching this video, you'll know why. Yeah, it's the computer sucks, and some are better than others. So I'll probably have to fix that one. Is it pretty bad? Yeah, it's pretty bad. Yeah. So we'll probably have to fix that one. Some of them you can fix, and some of them you can just it's fine. It gets through it. It lags a little bit, but it still works. Okay. We're going to multiply binomials by binomials. We're going to start with algebra tiles again, just to represent what binomials look like. Okay, again, you do not need to know how to do these algebra tiles on a test. So the first one is already all done for you. They have the question above. You have an x plus 1 multiplied by an x plus 3. That's a binomial right there, multiplied by another binomial right there. To use algebra tiles, we kind of set up a little diagram, and down the side we put one of them, and across the top we put one of them. So across the top you'll notice there's our x, and there's our plus 1. Down the side you'll notice there's your x, and then there's your plus 3. And if you look in the middle, these things should be creating little spots just like yesterday. So when you find their cross section, the x and the x create this little x squared. Yeah,
So does it kind of work with times and x?
Yeah, algebra tiles are good for basic questions. They don't work for x2 times x3 because we don't have an algebra tile to represent x to the power 6. Right? There's a limitation to algebra tiles, which is why you won't be tested on it. Also, it's time consuming to draw all these out. But it is good for some people just to see the representation of what I'm saying. So over here, we got this single x by going x times 1 creates x. Now we can do the same thing. So we have x times another 1 creates an x right there. A 1 times a 1 creates a 1. And you can see how all these little shapes are created. The inside tiles create the answer to your solution. So that's what's happening when you actually multiply things together. You're creating all these inside tiles. If we were to write it out mathematically, how many x squares are there?
1.
So we would say there's 1x squared. How many x's are in that diagram?
4.
So you'd say plus 4x. And then how many singles? There's 3. So plus 3. That would be your solution to the question. I want you to try to do the algebra tile setup for example 2. So even just the outsides, and then we'll do the insides together. My setup, on the top, I put the first binomial, the 2x minus 1. Did I have to put the first binomial at the top? Could I have put it down the side? I definitely could. It doesn't matter. So if you did the first binomial down the side, that's all right. If you put the first binomial on the top like I did, that's all right too. But what you do have to have is 2x minus 1, either on the top or down the side. The second binomial then has to be on the either top or side. Okay, once you have that built, you can build the inside. So if you have x times an x the inside would create an x squared. And it would be shaded in because it's positive. I then do that again for the next one. So I go over one, there's another x squared. The last one in that row would be an x times a negative 1 to create a negative x, so a non-shaded in bar. Now I do that for all the other spots. So I have a negative 1 times an x to create a negative x down here, a negative x down here. And this is a positive 1, because a negative times a negative is a positive. The one right below is actually the exact same. It's another negative x, another negative x, a little bit of positive. The algebra tiles in the blue represent your answer. So how many x squares do I have in the blue? I have 2x squares. How many x's are there? There's 5, and they're all negative, so I have negative 5x. And lastly, I have my 2 individual ones, and they're both positive, so plus. Again, algebra tiles are just really meant to help you picture what's happening when you're multiplying things. If algebra tiles are like, ooh, not your thing, that's okay. Now we're going to multiply binomials times binomials algebraically. And there's 2 ways to do it algebraically. Okay? You can pick which way you want to master, but you do have to kind of understand both. That makes sense. So you can do, like, you can pick one method and really stick to that one method, but you might have a question where it talks about the other method, so you still have to kind of know the other method. The first method is the same thing we learned yesterday. It's distribution. We also refer to it as FOIL. So you might see the word FOIL, or hear the word FOIL referred to a lot. That really just means distribute, which is what we learned yesterday. When we did distribution yesterday, you took your monomial and you multiplied it into everything in the brackets, correct? So if you're distributing with binomials, the reason why it's a little bit harder is you take your first binomial, this x minus 4, I'm just going to rewrite it here just for a second, and then your x plus 2. And now, because the first thing is a binomial, you have 2 things you have to distribute into the other brackets. So I take my x and I have to distribute it into the brackets. So it goes to x and the 2. I also have to distribute negative 4 into the brackets. So it's still the same thing as yesterday, it's just that you have multiple things that you're distributing into the other brackets. FOIL is a way of organizing your distribution. That is a lot of distributing, right? And sometimes people miss something or they get a little messy. So FOIL is just a way of organizing your work and reminding you how to do the distribution. Okay? FOIL stands for 4 different things. It stands for first. F means first. And that means you take the first term of each binomial and you multiply it together. So the first terms would be x and x. So the F in FOIL means multiply the first terms together. X times x gives me x squared. The O in FOIL stands for the outside term. So if you look at this binomial times binomial, you have 2 terms on the outside and 2 terms on the inside. See how that works? So the O stands for the outside terms. That's the x and the 2. So when I multiply the x and the 2, it gives me 2x. The I stands for the inside terms. The inside terms are these ones in the green. Two middle terms, so it's negative 4 and x, we create negative 4x. And the L in FOIL stands for the last term in each binomial. So f was the first term in each binomial, L is the last term in each binomial. So the negative 4 and the 2 last terms be negative. If you want to use FOIL, that's fantastic. If you want to just understand how distribution works, that's fine too. When you multiply those things together, you create 4 terms, right? You have x, 2x, negative 4x, negative 8. You write all those terms out in one long string like this, and then you combine any like terms you might have. In this case, we have 2x and a negative 4x right there. Those can combine to become negative 2x. The x squared and the negative 8 can't combine with anything, so your final answer would be x squared minus 2x minus 8. Okay, we're going to do a couple examples so you can see what it looks like. So the question here says multiply. Another word for multiply is expand. So if you read in your practice book the word expand, that also means multiply. So expand means the same thing. I'm going to use FOIL to multiply. The F in FOIL means multiply the first term. The first terms are these ones. Y times y gives me y squared. The O in FOIL multiply the outside terms. This is the outside term right here, and this is the outside term right here. Y times 4 would give me 4y. The I in FOIL stands for inside terms. The inside terms are right here. Negative 9 in the y. That would give me negative 9y. And the L stands for the last terms. So negative 9 times 4 would give me negative 36. That's FOIL. First, outside, inside, last. It's a way of organizing distribution. It's the same property, just a way of organizing it. You then take all 4 of your answers and you write them into one long word or problem. So y squared plus 4y minus 9y minus 36. And you collect any like terms that you see in that string of variables. Yep, because you're adding. So if you're adding terms together or subtracting terms together, it can only be same letter, same exponents go together. So where are my like terms in this one? The y's. I have 4y and negative 9y. So my answer would be y squared minus 5y minus 36. So if you're combining those like terms, you just go 4 minus 9. Gives me negative 5y's. If you're having trouble adding or subtracting like terms, let me know so we can talk about it. Remember that you could represent these y's as a thing. So it could be, you have, I always use cookies. You have 4 cookies and you have negative 9 cookies. And that leaves you with negative 5 cookies. The y doesn't just go away, it's still there. Alright, I want you to try to use FOIL on the next example over. So you're multiplying using distribution. FOIL helps organize your work. So, I showed my work on the board. The first thing I did was I did the FOIL. So I wrote out FOIL and I did each thing. If I'm multiplying, that means I'm adding the exponents. So x squared times x squared created x to the power 4. I'm multiplying to get my outside terms. So x squared times 5 is 5x squared. I'm multiplying to get my inside terms. So negative 2 times x squared is negative 2x squared. And then I'm multiplying to get my last terms, which is negative 2 times 5 to create negative 10. I then write out all 4 things. So all 4 terms I write in a nice long polynomial. And I look for any like terms. Sometimes there's not like terms. A lot of the time there is, but sometimes there's not. In this case, I had 5x squared and then negative 2x squared. Those can combine to become 3x. Yeah. If there's no like terms, then that is your answer, and you would just box it. Okay. This is also known as distribution. FOIL is just a way of organizing it. Okay. So if you hear someone say like FOIL that or do something like that, it only works for binomial and binomial. But what it is organizing your distribution method. The other way that we're going to learn to multiply things, and to be honest, it's the more popular way to do it, so this is what people usually end up sticking to, is something called an area diagram. Again, area diagrams are the same thing as distribution, it's just a way of organizing it. This is a little more organized than FOIL, which is why people tend to go towards it. So an area diagram is kind of like what we did with algebra tiles, but instead of using actual tiles, they write in the letters and the numbers. So the first thing they do is they create a little grid. Just like we would have done with our algebra tiles. So I did the grid in the black. And I take my first binomial, and I write it across the top. So I go x and then minus 2x. And I break that thing up. So now they're separate columns. I then take my second binomial, my x plus 9, and I write it down the side. So x plus 9. And I draw a line just to break it up. And you see you've created like a little grid where you have something across the top and something across the side. It's a lot like what algebra tiles look like, except now it's using actual numbers and letters on the outside. So if we were doing algebra tiles, it would have looked like this. You don't have to draw this. We would have gone x, so we would have gone negative 2. Okay, we did the same thing here, except it's just we wrote x and we wrote negative 2. Yeah. Yeah. Yeah, like if you just create the grid, yeah, it creates your boxes for you. Yeah, it does. Down the side, there's my x. And then instead of writing 9, we would have done 9 little boxes, which would have been a lot. See how it's kind of the same setup? Just like with algebra tiles, we have to figure out what goes on the inside of our grid. To figure out what goes on the inside of your grid, you take the column and the row, and you multiply where they cross each other. So x times x creates x squared. We then go to the next column with the same row. Negative 2 and x creates negative 2x. You go to the next empty spot. That's the cross section of x and 9 to create 9x. And then negative 2 and 9 creates negative 18. These 4 squiggly line things, that's your answer. Just like in algebra tiles, your answer is the things on the inside. We write them out as one long polynomial. I know it's already written out for you, but I'm going to write it out again. So those are the 4 things from the inside of my area diagram. And just like FOIL, I combine any like terms. those are like terms. X squared plus 7x minus 8. The idea of distribution, like, so anytime I ever ask you to multiply something together, especially on a test, you can use any method you want. But have you ever seen those questions where it's like, where's the mistake? You know those ones where it's like, here's someone's work. Where did they make a mistake? So if they do FOIL in that question, you have to understand what's going on, or else you'd be completely hooped on that type of question, right? So that's the only time that you would be stuck doing FOIL. Most people like area diagrams, just being honest. All right, we're going to do 2 more together. So example 1 down here, they've created a grid for you. To use an area diagram, we take the first binomial, the x minus 11, and we're going to put that on the top of our little diagram that's been drawn up. So I'm going to go x minus 11, like that. The second binomial, that one's going to go down the left-hand side, so it's x and then plus 7. Now you fill out the inside. You do it using multiplication. So you're not adding the rows and columns, you're multiplying them. So if I go x times x to create this middle, that would be x squared. Negative 11 times x would be negative 11x. Along the bottom, x times 7 would be 7x. And negative 11 times 7 would be negative 77. You have 4 things sitting there. You write all 4 out and then combine any like terms that you have. So this would be x squared, I'll move this all up in a second, minus 11x plus 7x minus 7. That's all my things in blue. Written out into one polynomial. Anybody have any questions about that so far? Yeah. Yeah, the 7 and the negative 11 are like terms, so they can be combined. That means my final answer would be x squared minus 4x minus 77. And I can't do anything else because none of them are like terms. They all either have different letters or different exponents. Yeah, Kendra.
When you're just writing it out to combine terms, does it matter what order you take them?
No. Typically what you'll see is you'll see descending order. So the highest exponent will be written first, and then the next highest.
I'm just wondering, you know, like figure.
You can write it out any order you want. The reason people like area diagram is area diagrams work for all types of multiplication. So you could technically do an area diagram even with a monomial times a polynomial. It's just your grid would be a little bit smaller, right? You would only have one thing on the top, and then you'd have multiple things down the side. If I gave you a 6th thing times a 6th thing, you would have 6 terms across the top and 6 down the side. It would just be a really big grid. That's why people like area diagrams, because they work for all questions. FOIL only works for binomials times binomials. That's why FOIL is kind of limited. Both are just ways of organizing distribution. So if you like distribution, then you can still do that for every question. I want you to try number 2 by yourself, using an area diagram. And then number 3, we're going to talk about before you start it. Okay? If you're feeling a little crazy, go ahead, but there's a trick to start it off that I don't want you to mistake. All right. we can do pretty good so far. So I look at this, I see I have to multiply. I'm going to use area diagram. The first one, y squared minus 4y. I write that across my top. My next one, which is y plus 2, I write that one down this side. That's how I create my diagrams. I know you can do a much more organized way of doing it, but it works for me. It creates my grid properly. I then fill out the inside of my grid by multiplying. So if I multiply y squared times y, what do I do to the exponents when I'm multiplying? I add them. Y to the power of 3. I then go y times negative 4y, that gives me negative 4y squared, because I add the exponents. My next one would be 2y squared. My last would be negative 8. Looking at this, I have all my blue on the organized inside. I write them out into one nice long polynomial. And I look for any like terms. And I combine those like terms. Notice that it's still y squared. Okay? When you're combining like terms, you're only focused on the coefficients, the numbers in front. Any questions with that one? Yeah. Oh, no, you're good. The last one. So this example 3 has a trick to it. The trick is that squared cannot come into the brackets, which is what we want to do. Like instinctively, people look at that and they go, squared goes in the brackets, because that's what you learned last unit, was that squared outside the brackets comes inside the brackets. The reason you could do that last unit was you had monomials inside the brackets. If you have a binomial inside the brackets, you cannot do that. Instead, what you have to do is this squared means that there's 2 of them. So I'm going to rewrite it as rs minus 8 times rs minus 8. And I'm going to get rid of that square. If it was cubed, I would write 3 of them, right? So if you had 3 in an area diagram, that's a good question. So say pretend there was another one here. There are no space, that's okay. I would multiply the first 2 together to get an answer. And this answer would then have to go with another area diagram times the next one. So you'd have to do 2 separate area diagrams. You would do one part of the question, get an answer, and then you would go your answer times your other one. You'd have to do it an extra. In this case, there's only 2 left, so that's good. Save those. Now that you know it's rs minus 8 times rs minus 8, you know you can do an area diagram. On the top of the area diagram, I have an rs minus 8. Down the side, I have another rs minus 8. Notice that the rs's didn't break apart in the area diagram. The r and the s are still together because they weren't separated by a plus or a minus sign. So the rs stayed together in the area diagram. Don't break it up. Now I fill out the inside. rs times rs would be r squared s squared. Right? Letters go with letters. So r and r could multiply together, and s could multiply together. It doesn't become 2rs, which is what I think a lot of people would do. R squared s squared. The next one would be negative 8 rs. The next one would be another negative 8 rs. And the last one would be a positive 64. any questions about that area diagram, because there's some tricks to that. Alright, take the inside, all the stuff in the red, write it out in one big sentence. You can find any like terms that you have. So I have an r squared s squared. I don't have that anywhere else. But I do have an rs right here and an rs right there. And those ones can be combined. My answer would be r squared s squared minus 16rs plus 16. That would be my final answer.